I'm going to get started grinding here. So here's our intake sides. This all orientates like this. The intake charge comes in, hits this back wall, comes in, hits this back wall, and then we need it to flow into these transfers generously. So I'm going to open up a whole lot below this bearing pocket here, and I'm going to take out this divider wall here between the two transfers. And I'm just going to start on that work on just one side for right now, so we can kind of see a comparison between the two before I get carried away and get it all done. Okay, see if I can get that to focus without too much glare. Yeah, there you can see in comparison here, this sharp corner we can't really get around to here. We've got a whole groove we can move through now. So now I'm going to move over here and take this down. I have left the bearing seat here, but then undermined it for airflow. And now to this side. Okay, there's that case half, and I'll do the other side. Okay, here we are before I clean it out. Got a couple of channels opened up here, channels here, but leaving the bottom seat for the bearing. Some really big channels over here on the exhaust side, where the intake comes first to bounce off of to lead into the transfers. And I'm going to stop here, clean it out, and then map out my exhaust and intake port. Okay, real quick, our new weight of our cylinders, 513, 514 grams, somewhere between 10 and 11 grams lighter. And this is just with lowercase work. I haven't done anything to the top yet. So let's write that down, 514. So we've removed 10 grams of aluminum from the lower case, plus the 5 grams of aluminum removed from the crankcase side of the piston, so that's 15 grams of aluminum. And then total steel removed, we've removed 348 to 371, so 23 grams of steel. And I went ahead and looked it up. Basically the density in grams of cast aluminum and cast iron. Cast aluminum is 2.7 grams per centimeter cubed, and Cast iron is 7.8 grams per centimeter cubed. So that should give us an adjusted volume. So a little bit of quick math there. The 15 grams at 2.7 grams per centimeter cubed gives us 556 cubic centimeters. And then on the cast iron, we've gained almost 3 or 2.95 cubic centimeters. Add those together, we've essentially added 8.5 cc's of volume to our crankcase. So that would be available intake charge or case volume, if you will. I don't know if that's a good thing or not. I've heard the increased case volume can add to torque, and we'll see if that pans out. Alright, just a quick recap here. As much for me as anything. Stepped away for a couple of days. We've got our lower case work done, got our crankshaft done, our piston work done, and by math of weight, we've added 8.5 cc's of volume to the crankcase, which should, in theory, help us store more air fuel mix down there so that we can make more power, make more torque, hopefully move a higher amount of torque further up in the RPM band. We've also moved our exhaust from the factory cheap eBay cylinder 94 degrees down to 97, maybe 98 degrees. It's right there in a gray area. Squish is now 22 thousandths instead of 40 thousandths, and we achieved that by milling our squish band in there. I say milling by hand, but still we machined it. Is it machining if you do it by hand? Because that implies that we used a machine. I don't know. Anyhow, we machined it by hand. 22,000 squish, and our next step here is going to be our next step is going to be, let me find my pointer. Our next step is going to be coming in here on the intake side and tapering up this transfer and possibly broadening it out. I had talked about maybe putting in finger ports. I think I want to hear this engine run before I do more things that I've never done before. I've never machined this squish band like this the way we just did. Let's do more things that we've already done before we go changing even more. So I'm going to widen this transfer up slightly and move it up just on the intake side. This will be so that we charge our intake charge above the intake first, which will help us force the airflow out through the exhaust. We're going to lung the intake here and here and add some texture to it, and then we will widen the exhaust pretty greatly. So I will get started on all of that. We also still need to come in here and dress these seal pockets so that they are able to take a seal. Let's see where we're at with that. This goes in here. How far off are we? We've taken quite a bit. Oh yeah. Yeah, we're gonna have to take a lot out of that seal pocket. So you're at a bad angle here. There, you can see that seal won't fit in there with the way it is, so we'll have to take a lot out of the seal pocket, mostly out of the bottom side here, because we moved the whole crankshaft closer to the top of the cylinder head. So those are what's next, and I'll get started. All right, first things first, I'm gonna do the upper transfers. See if I can do this here on camera. The bit I've got's just got a flat end on it. It's tapered. This is just that cheap Amazon set. I've seen other porters on YouTube use the same one. I don't know how much it is, 14 bucks, 17 bucks, something like that. And I'm just gonna come in here and move that transfer. Okay, don't know how much you can see there, but I just touched them in the corners, gave them a little taper up so they'll open a half a degree, maybe a degree before the other transfer. That's it. All right, I've just got a taper bit on and I'm gonna lung the top of my intake. All right, I'll stop it there. It's got a nice long or heart shape to it. There it is from the inside. Now I'm gonna widen my exhaust. All right, so that's the porting work done. That honestly took about 10 minutes. Everything else takes so much longer. So the exhaust port is greatly widened. The transfers are moved up, just pitched up in the intake side, and the intake is lunged to a heart shape. So I'm going to sand on this for a little bit, get it all cleaned up. Then we will put it together, time it, to see where our numbers ended up, and then we'll work on the seal pockets. Okay, all the sanding work is done. So the port work is done, exhaust, intake, transfers. There's the intake, kind of heart-shaped. Here's the exhaust, not much different, just widened quite a bit. And then sanded. I don't have a split mandrel for my Dremel, so I just take a bamboo barbecue skewer, put a little bit of emery cloth in it, and then run that in my drill. That's all I do for sanding, if you will. And then I chamfered everything inside with 600 grit wet dry. Time to put it together, just make sure it free spins, and then make the seals fit. Alright guys, the next thing I'm doing here is I'm just checking my ring gap. I've got my ring in here, pushed it down with a piston, and I've got 3 rings to choose from. I'm just checking the gap on each of them as it lines up right over the intake. I've got one at 18 thousandths and 2 at 14 thousandths. I'm gonna use one of the rings with 14 thousandths gap. I think it should ideally be a little bit tighter than that. Maybe somebody can help me out with what an ideal measurement is for that. I'm running one ring on this piston. Okay, I've done a few more things here. Here's the last shot of my exhaust port. Just cleaned up with a split mandrel, widened, not raised. And the intake with that heart shape or lung shape to it, widened pretty extensively. Our trenched case and trenched transfers, cut bearing pockets, cut seal pockets, cut squish band, overall squish of 22 thousandths. Got just a top ring on our piston. Went ahead and left the tabs on both of the wrist pin snap rings because I expect this build is for me, and I expect to be in here in the next few tanks of fuel just to check on everything, make any adjustments as necessary. We've got a pretty heavy molybdenum based grease on all of the bearings, both seals slipped on, and getting ready to check final fit before we put on the moto seal. Okay, there's a coat of grease on the cylinder wall, coat of grease on the piston. Intake's away from us, intake on the piston is away from us. And just slips right in. Down. Line up these seals a little bit. That'll go. Okay, gonna grab my moto seal. I don't know how most people put this on, but I just paint it on with a fingertip. Put it on just a little bit thick. Not gobs of it, but coated like a coat of paint is how I do it. And I cleaned off this surface with brake clean prior to the moto seal here. Okay, one good layer of moto seal on. Bearing pockets included, or not bearing pockets, sorry, seal pockets included, not the bearing pockets. Set this in here. Press it down good. Make sure we rotate. Yeah, well, that seal is rotating. That's okay. Set this one on here. Move you guys a little bit. And drop 4 bolts in here. Torque it down. And I'll let it dry for a few hours and go get some work done. Then we'll put it in a case. All right. Stihl 25C, the fresh rebuild, the adjusted squish and squish band. So this particular saw came with a carburetor that is only adjustable on the low side, not the high side. I'll want to change that out. I didn't notice that before I started the build. I have already started it once. Let's see how it goes. It's a good sign. and go cut wood.